So first, I've been downloading the various homeworks that are coming in for number 2. And I have to say, some of you made some really beautiful worlds. I really enjoyed exploring some of them. Thank you, everybody who zipped up their game folder. Turns out that if Safari for some reason won't download the Google zipped up things, I'd have to go into Chrome or something to do it. But thank you for zipping things up. So let me start sharing screen here and clean this up a little bit here. So last time we talked about prefabs, easy to duplicate and maintain objects. The nice thing about prefabs is that you can make many instances of the prefab, and if you go into the editor and open the prefab and make changes to it, all of your instances will change. You can edit individual instances in the hierarchy, make changes to them, and it doesn't affect the other ones, but there's a button that you can press that and puts it back into the prefab and updates everybody. So a good thing to have. We also talked about textures. I think we made some simple textures, an all red one. I imported a checkerboard texture that I like and made a material that is a checkerboard. And we talked about context layers, which we'll use extensively with our different cameras and other things. There are built-in layers and you can define your own. We made one called custom ignore. And we saw with the camera that if we turned off the camera's ability to see custom ignore, that all of those objects that were in that layer disappeared. I talked about the console, the place where you'll see error messages. You also see them down in the lower left-hand corner of your editor, but they all kind of flow by. If you open the console window, you get to see them. And we saw there were 3 different kinds of debug messages that you can put in your program. There was just the debug log warning that makes a little yellow sign, and the debug log error that if the console is set to pause on error, will stop the game from running at that point, which is kind of nice. You can put a breakpoint in your program that will then stop when you need to. It's also where any compile errors occur. I did see a couple of homeworks that had errors in them that were uncorrected, which meant that they weren't able to run their game because Unity won't run until all syntax errors are cleared. And these were the forced reset and the simple menu activator that came from standard assets. And you can just delete those and the errors will go away. We did a simple animation. At least I think I did a simple animation where we set up a cube, opened the animation window, made clips and moved things around. We saw these curves that will crop up in a number of different contexts that we can put new breakpoints in, or new keyframes in. We can adjust slope and do all kinds of fancy stuff. I'll come back and do more with animations later. And the last thing that I recommended was to organize your assets. Don't just leave them all in the root, but kind of sort them into materials, textures, scripts, scenes, prefabs, other kinds of stuff. So I'll stop here for a minute and entertain any questions on that past material. Any questions? No? Okay, so I think the next thing that I did was play a little bit with LERPs. And so we looked at some of the issues that crop up when you import assets either, and there were a number of different ways to do this. We could import a package. So let's get LERPs up here. We could import a package by assets, import package, custom package, and then go out and find the package on your disk. But we could also just drag and drop a folder that contains our stuff into the assets. This is how we got this one in here. We just dragged and dropped it into the scene. I mentioned the different issues that crop up with the import. Things often, stuff that comes from content creators has a scale factor set at 0.001. And while you can scale the object with the transform settings, it's better to scale it here so that it assumes the proper size. That little convert units does kind of a similar thing. So if your object is coming up too small or too big, this is one of the places to look at the actual model that is made by external content creators. The little LERPs character, you notice, is a prefab. It's blued out here. If I ask it to select the prefab asset, it goes to its location in the project view, shows me the prefab, and I can look down through the hierarchy and see what the different pieces of LERPs are. At the top here is kind of this empty game object that just has a transform on it. It has an animator too, but I took it off. And here is the model of LERPs. This is the thing that the content creators make, and it has what's called a skinned mesh renderer on it. There's mesh renderers that have our materials, but the skin mesh renderer is different in the sense that it moves with the bones of the object. And so this is what we usually use with our animated characters because this mesh will move with the underlying bones. And here's the material that LERPs has applied to them. And the material is over here in this material folder. And it has various maps that we'll talk about when we get to materials. But in particular, it has an albedo, which is basically the map of textures that go onto LERPs. This is the albedo texture. And we also have on this texture a normal map, which is a way of making things look bumpier than they actually are. And that uses a normal map or a bump map texture that has some magic in it. They tend to look purple like this, and they have information that the lighting engine uses to apply bumps to our character. Now, one of the things I'd like to show you here with LERPs is the ease with which we can make adjustments to some of these things here. So I'm going to click on this texture here, and that opens my Photoshop with that texture. And we don't need to know anything about how any of this magic works of the mapping of this texture onto our character. That's all done by the content creators, and it is a lot of magic. But Lerps here has this little eyeball, and if I use my magic selection tool to select that, and I now, I think this is what I want to use to, oops, not what I want to use, this one. I can now paint his eyeball red. And if I just save this and go back to, I'll save it and replace it. And if I go back to my world here, notice already, it's already imported the texture, it's already incorporated the change. And if you look at Lerps, he now has a red eye. So all that's very cool and very easy to do. You can edit these textures with either GIMP or Photoshop or whatever tool you have. Incidentally, that tool is selected in Unity preferences, external tools, and here my image application is Photoshop Elements. My external script editor is Visual Studio. So whatever tool you have, you can hook it up there and have access to Unity's materials and textures and so forth. So pretty cool. So let me show you one other thing here. This other Lerps who came from this artwork, he has an animation component on it that has all the different animations that he has. He's set up to do the walk. And so if you watch the other Lerps here in the background, he's animated. And that's the kind of thing that that we will use when we go to animating our characters. So let me switch here to, let me close this one and I'll save it. And I'll quit this too. So the next thing I want to talk about is cameras. And I did show you a few of the things with cameras, but in particular here's my scene with cameras. And I've got a camera here, and I've got this in wireframe view, so hopefully we can see the volume that the camera sees. The camera sees a truncated pyramid called a frustum, and what we can see is everything that's inside that volume. And this projects out of the z-axis of our camera. So if I look at specifically at the camera, I can put this in local so that I can see the local objects axis. You'll see that the camera is projecting out of the blue axis of my camera, and that's the forward direction of the camera. So, so we can do a lot with the camera, and it has a lot of different properties. One of the things is the clear flags. This is what it sees when there's nothing else there. And so the clear flags here on the camera are set to be the skybox. So this is when there's nothing in front of the camera, no object, this is what it will see. But we can also set this to be things like a solid color, in which case what the camera sees is this brown color, and depth only and don't clear, don't fool with them. Those are for debugging purposes. but I'll leave it to the skybox here. So that what the camera sees when there's nothing else in front of it is the skybox. I already showed you the culling mask. This limits what layers you can see. And so I believe that this ball here is in the layer custom ignore. Let me get that out of the way, custom ignore. And so if I switch the camera here to not see the custom ignore, that ball, oh, and lerps apparently is in the custom ignore as well. They disappear from what the camera sees. The viewport reticle, rect is where the camera window appears in the game view. And so the rect here has a lower left-hand corner X and Y position and a width and height. And so I can make the width smaller and my camera view in the game window now only occupies half of the width, and I can move that over and move it around and up and down. And so I can place this camera window wherever I want to in the scene or in the game view. And we'll use this with, if we want to have like multiple cameras in our view. X and Y are the lower left-hand corner going from 0 to 1. W and H are width and height also going from 0 to 1. So a full screen is 0, 0, 1, 1. A camera has clipping planes. There's a near clipping plane that we can't make any smaller than 0.1. You can type a 0 in there and it will immediately go back to 0.1. And this has to do with the mathematics of projection, three-dimensional projection. The mathematics do not allow the near clipping plane to be at 0. But if I increase this, what you'll see over in this window, as I increase this, you can see that pyramid being truncated close to the camera here. And as I move this further and further out, less and less of my world is inside that volume and I can't see it. Let me set that back to 0.1 again. And the far clipping plane works the same way. If I move it back towards the camera, eventually here, I'm going to start truncating things far away. So this is kind of how far the camera can see. And for the mathematics that we don't need to know anything about, the goal here is to make the near clipping plane as far from the camera as you can, and the far clipping plane as close to the camera as you can. This has to do with how the perspective projection deals with overlapping objects, determining who's in front of whom. So that's the near and far clipping plane. Generally, you can just leave it to what the defaults are, but if you're working in a giant world that has things that are more than 1,000 meters away, then you might want to move your far clipping plane out so that you can see things in the distance. But if you move the far clipping plane too far and near is too small, you'll start to see some weird artifacts. The field of view, and incidentally, all of these things can be adjusted with the gizmos over here that let you, I have to have this on. You can adjust these things with the gizmos. So here I'm adjusting the field of view right here, this field of view, which I can slide around like this. So if I make the field of view very wide, a very wide angle camera, it kind of makes us feel like we're far, far away, but I can make this into a telephoto camera that has a very narrow field of view and is kind of zoomed in on objects. And I forget what the value was that I had there, 43, okay. So we have this near and far clipping plane that defines the volume in which we can see our objects, and the field of view that defines the angle of our that our camera sees. I believe there's also an aspect ratio setting. Is there aspect ratio? Well, you can define which axis the field of view is defined by. In this case, it's the vertical, the upright in the camera. Now, the projection that I'm showing here is perspective, which is our 3D perspective, where things that are further away from the camera are smaller, things that are closer to the camera are larger. This is what we usually use when we're playing with a 3D game. But there's another one, which is orthographic. And orthographic is where parallel lines are parallel. So this is not physically what we would see, but it can be useful for certain types of cameras. I'll put this back the way it was. And one of these cameras might be a top-down camera. So here's a camera that I had turned off, the top-down camera. And you'll notice I've set its width to be 1/4 and its height to be 1/2. And so I have this top-down view of my world, kind of a map camera that helps me know where my character is in the world and what's going on in there. Now, an important thing, and it's an orthographic camera. If I look at the orthographic camera, its viewing volume is a rectangle, and we can change the size of this rectangle, of this cube, with the gizmos here. If I can grab it. Unable to grab it, but I can change its size here and adjust how big that rectangle is. It has near and far clipping planes as well. And importantly, it has something called the depth. Now, the camera that is looking into the world, this perspective camera, is at a depth of -1. And the top-down camera is at a depth of 0. When Unity renders what the different cameras see, it starts with the lowest number, -1, renders it, and then it goes to the next highest number, 0, and renders it. And so this ends up being on top of the view here. If I set this to -2, it disappears because it's behind the -1 texture. And I'll set that back to 0 so that we can see it. So I have now kind of a map view. And so if I play the game here, I believe LERPs, this is a wired up version of LERPs that we can walk around in the world, and he can push balls and do other things. And notice down here in the map view, I can see my little LERPs character moving around on the map. I can see the ball rolling around, and I can see this cube that I've got sitting here. So all very good. And we do this to make a picture-in-picture. And it's important here that the cameras utilize the culling mask. For instance, if I don't want my top-down camera to see the character, I could eliminate the custom ignore, and the top-down camera only shows things that are not in the custom ignore layer. it doesn't show my LERPS character or the bouncing ball anymore. So we can cull using those context layers to make things invisible in the game view. So we have more than one camera active in a scene. And by the way, cameras have audio listeners on them. And this is, we'll get to sound later in Unity, but if there is any sound in Unity, the place in the world where it's picked up is on the audio listener, which is usually attached to your camera, because that's kind of where we hear the sound. And if you happen to have audio listeners on both cameras, you'll see this constant warning in your console window. There are two audio listeners, and it just keeps saying this over and over and over again. And this can actually flog your performance, since stuff is happening in the console window. And so if you have more than one camera in the scene, it's important to turn off all but one of the audio listeners. Let me pause here for a second and see if there are any questions at this point about the cameras. No? Okay. I see lots of names in chat. I'll remind you to put your names in chat if you haven't already done so. So I want to set up a really simple script here. I'll call this smooth look at, and it has one method in it, one function, the late update. There are two update functions. There's update and late update, and the only difference between them is late update happens after update. And I have various public variables here, the target, a float to control damping, and a Boolean as to whether I want to use smoothing or not. And I've put that, or I'm going to put that on the camera here. So let me find that script. Here it is, smooth look at. And there are a number of different ways to put a script on an object. One, you can just kind of drag it over and drop it on the inspector. And so that's put the smooth look at script on my camera. Alternatively, you can add a component. And so if I look for the smooth look at script, I can add it that way. Now I actually have two smooth look ats. And because this smooth look at has this special directive in it, the add component menu and then camera control smooth look at, having this directive in the script means that my component menu here has a menu option that I've specified. So this is not one of the standard ones. This is the one that comes from this script, and I can add the smooth look at that way. So I can either drag and drop it, I can get component it, or if the script has this magic directive in it, I have my own menu entry for entering it. Let me get rid of the extra copies here. I'll remove that component, and I'll remove that component. You don't want to have multiple copies of the script. Now, the public variables public transform target and damping and smooth, these show in the inspector. They're here in the inspector. There's the target, there's the damping number, and there's the smoothing. Now the target, it doesn't have one yet. And so if I run this, I might get a console error, or I might not. No, I have an error trap in here. If the target's not defined, then it doesn't do anything. So I've put an error trap in here so it won't break. But if you didn't have that test in there and the target weren't defined, you would see a null reference error in your console, and you'd know that you had to go back and do something to fix it. Now, I can make this smooth look at follow various objects. Let me make it follow the bouncing sphere. So I'm going to drop that into the target slot here. And whoops. And what this does, if my smoothing button is not on, all it's going to do is use a transform method. Transform is position, rotation, and scale. A transform method to look at the target. So this is just going to point my camera at whatever I want it to look at. This stuff in here with the smooth is some fancy stuff so that it doesn't immediately go to the target, but it instead slurps to it. Slurp stands for spherical linear interpolation. And this is some fancy stuff that we'll get to later. But the bottom line here is I've got smoothing turned on. Let me turn smoothing off. And if I run this now, you'll see that my camera tracks the bouncing sphere. Oh, that's a little bit seasickish. Now, alternatively, we can track lerps. I believe if I click here, I have all of the different things in my scene that I can track. So let me track lerps's head, I guess. I don't know. And so now the camera is going to track lerps. And when lerps moves around the scene, the camera rather nicely follows the character. Lerps can push this cube around or interact with the bouncing ball, and the camera is following the lerps. If I change that to smoothing, if I turn that on, and the nice thing about these public variables is you can change them in the inspector. You don't have to go in and do it in the script and recompile it. So this is very convenient. It gives us a way to access what's going on inside the script without having to do anything fancy. You notice that damping has a default value of 6. So if it has a default value, that will show here, but I can of course change it to 5 and my damping will be different. I don't have to go in and change it in the script. If I reset that script, it'll go back to 6, and it also went back to none, so I don't want that. Whoops. I want to drop lerps into the target. So now with smoothing, and that 6 is just a parameter that lets us adjust how much smoothing there is. The camera is no longer quite so rigorously following lerps. There's a little bit of lag where it kind of adjusts more slowly. So that's our first script, and it's really simple and very powerful, and it uses a lot of different things from the Unity API that do a lot of the work for us. Look rotation is kind of like look at and slurp is something that moves from one form to another. We'll talk about them in much more detail when we get to scripting. I just wanted to show you this. So we've added smooth look to the camera. We looked at different ways of doing it. We have our sphere that we set as the target, and it then follows that transform around. The sphere had a rigid body on it, which is what made it fall, and the collider used a physics material that was set to be bouncy. And I warned you about the two audio listeners that are on the different cameras. So all of that's good. Let me pause here again for any potential questions. I'm moving fast here with a lot of powerful material, but
excuse me?
Go ahead.
Have you posted where we could find the like the smooth follow with the camera or that script? Is that on the Brightspace somewhere, or would we have to find that online?
No, this every in-class demo that I show you guys ends up on my Google Drive under posted notes. If you go to Brightspace, I believe there's a link to posted notes, and that's on my Google Drive, and I post both the slides that I'm showing and all of the in-class demos that I'm showing. And I usually use a low number of 219, so it's easy to upgrade them to higher versions of 219 or 2020.
Okay, thank you.
I believe the wired up LERPS character is also in the Google Drive under packages, or so the wired up LERPS character that I showed walking around there is also on the Google Drive. I give you everything. You can use anything I give you. And I encourage you to use anything I give you. Anything else? Okay, back to sharing screen here. Now, another kind of interesting thing we can do with cameras, we can render to the game view. That's the kind of standard thing we do with cameras. But another kind of tricky thing we can do with cameras is render to a texture. And so let me get in a different scene here. And I'll save that. So here, instead of having a top-down map camera, instead here, I've got this, whoops. Well, I'll fix that in a minute. Instead of rendering to, in fact, let me fix it now. The map camera sees everything, and I don't want it to see custom ignore. No, I don't want it to see transparent FX. I don't want it to see whatever that arrow is. That arrow is in layer default. Let me put it in custom, in transparent FX, change all the children, and go back to the camera and change it so that it doesn't see transparent FX. And the arrow is in transparent FX. That should have disappeared. Hold on, let me fix this. The arrow is in transparent FX. And the map camera is not seeing No, the map camera wants to see transparent FX. I'm sorry. It's the first person character camera that doesn't want to see the transparent FX. I want the little arrow to show on my map. So I've got this map camera that's a top-down view. Here it is over here in the camera preview, but I'm not displaying it on the screen here. Instead, I'm having it target a texture, the map texture, which is a texture that I made here. It's a render texture. It's a little different than the other textures. When we make, where is it? Oh, I'm sorry. When we make render textures, where's render textures? Render texture. These are textures that are going to be written to by a camera. And so this map texture is a render texture. We have things like its size, what its resolution is, and the camera renders to that texture. Now I have a material, the map material, and it's an unlit texture. We don't want shading and lighting on this thing. We want it to be plain unlit. And it's connected to that map texture that is written to by the camera. And so this physical object, which I have kind of attached to my character, and I can turn it on and off with the M key, this kind of shows me the map of the world, and you can see my little red arrow, which I can't see because it's in my culling layer, but I can go over, I can wander over here and jump in the hot pit, and I've got this map view in front of me that is a physical object that is part of my character. If I look at my first person character, I have this picture frame out in front of me. Let me go into wireframe so we can see it, or into shading so we can see it. And so my character, which is a first person that doesn't have any visual at all, has a camera on it. It has this picture frame that I have positioned out in front of me, and it has the arrow that I want to be able to see in the map view, but not in the first person character camera. And so I've made this object. It has a transform. It has a mesh renderer that has, it actually has two materials on it. One is art, which is this frame that goes around it. And the other is the map material, the thing that the material that has the map texture that is written to by the camera. And I've got this little script here, is visible, which is a very simple script that just basically turns things on and off depending whether I press the M key. It toggles the renderer on and off. And we'll talk more about these kind of tools, but that's a very simple script just for toggling it on and off. So here's the simple script. It has one public variable visible, a Boolean. It's by default true. And here, when I press the get key down, M key, it toggles whether the mesh renderer is enabled or not. It says mesh renderer enabled is equal to not mesh renderer enabled. So it just toggles it back and forth. Much more on scripting later, definitely. So any questions at this point? That's a pretty cool trick that we can render textures to objects. We can put what the camera sees on an object. You can make a little TV in your game that is rendering a camera that's somewhere else in the scene. So you could have like a CCTV kind of thing set up with a surveillance camera over here showing what is seen on a TV screen in your little control center where you were watching for enemies to come along. So very cool stuff we can do with cameras. Any questions? Okay, well, I don't have a lot of time left here, but the next thing I want to talk about is light. Let me save this scene and go back into the camera scene. And I'm going to quit this version of Unity and look at the next one here. So light is everything in Unity. If we have no light, we see nothing. It's all black. So every scene in Unity has to have some light in it. And if we make a new scene in Unity, it automatically has a light in it. It has a directional light in it. And this directional light has certain default properties. It's of type directional. It has a color, kind of this little bit of yellow. It has intensity and some other stuff that we'll talk about here. But there are a lot of other types of light in our world. And one of them that I mentioned with the skyboxes is the ambient light. Now, directional light has a direction. It's coming from someplace and it's going in a direction. And so it casts shadows, because if you're in front of the light, you cast a darkness behind you. But ambient light is light that is everywhere, and it's uniform everywhere, and it's calculated from the skybox. So here in my lighting window, and this may be different if you're using Unity 2020. In Unity 2020, there's also an environment button which is where one specifies the environment lighting. So the environment lighting here is coming from the skybox. And so there are no other lights in this scene. Here's where the Light Explorer is also kind of useful. The Light Explorer shows me that I have a directional light and I have a jet light. The jet light is LERPs's light. Notice it's turned off. And if I play LERPs, watch the jet light little button there. When LERPs jumps, the jet light turns on, and you can see him casting light in the scene. Now, what I've done here that's a little bit fancy with the ambient light here is controlled by this intensity multiplier. And if I turn this down, the ambient light goes away. If I turn it up, the ambient light gets much, much brighter. And let me set that back to the 0.83 that I had before. And there, it got back to it. So the other thing that I've got here, I believe on my light here, I have an animator that is going to turn my directional light around. And so, but my directional light has an intensity of 0. So it's not actually making any light in the scene. But the procedural skybox that we're using here has this special property that it knows which light is the sun. And if you don't specify it, it will pick the brightest directional light. but I've connected the sun source to this directional light that that has this animator on it that is going to turn it so that we get this kind of day-night cycle. And so if I maximize here so that we can see this happening, the light is turning so that the sky is dark, in which case there's no ambient light, and then it's turning so that the sky is colored, in which case there is ambient light. So we can adjust the intensity of this ambient light with this slider here. We can also set it to be just a color. So here now the ambient light is this red color, and now all of the ambient light, you see that it takes a little while for that to appear. And then there are also things called gradients, where we can set the color of the sky, the color of the equator, and the color of the ground. And this will project ambient light into our scene. From above, we'll get red, from below, we'll get ground, and from the sides, we'll get equator. So we can do a lot of fancy things here, but at the very least, we'll use the skybox. So next time I'll continue on with the other kinds of lights, the point light, spotlight, area lights. I'll do more with directional lights, and I'll show you all of this stuff and how we set up and use lights. So I'll stop sharing at that point. I've gone a little bit over. I apologize. Any questions? People are fleeing as fast as possible. Okay.
For the window where you painted Lerps's eyeball,
Yeah.
how did you get to that window?
Well, let me share screen and I'll show you. So in Unity, under preferences, under external tools, the image application is Adobe Photoshop Elements. Now, if you don't have Photoshop, you can get the free GIMP program that does essentially the same thing, and you could put it there. And this is just a pull down. You find the different, you browse for the program that you want to open. So with that set up, if I go to any of the textures that I have in my scene, so where's a texture? Probably here. Here's a texture. So there's my texture, and if I double click on that, it opens Photoshop Elements with that texture in it, and I can then edit it. When I save it out of Photoshop Elements back into the game, it automatically updates it. So that's all you need to do. That answer
Awesome.
the question?
It does. Thank you.
Okay. You need some kind of photo editor. Photoshop, if you can afford it, is great. Photoshop Elements is expensive too. GIMP is free.
Perfect.
It's from the GNU program people.
Wonderful. Thank you so much.
Okay. Anything else?
Hi, Professor.
Yeah.
So when I did the homework yesterday, and I realized that when you use the terrain toolkit to apply different effects like erosions to the terrains, can you select like a area that you want to apply to, like without affecting other areas?
With the toolkit,
Yeah.
it's kind of kludgy, but the toolkit will let you paint erosion onto the scene, I believe.
Yeah, there's a brush, right?
It doesn't work very well. I found it
No,
to be
it doesn't.
pretty glitchy.
Yeah, it's
If you download the Unity terrain tools, that's the only way that their erosion tools work. They are paint-on tools. So you could try the Unity terrain tools because they're a little better integrated with Unity. But yeah, the only way to have the erosion behave in one place is to use the paint tools. And I found the paint tools to be, I haven't actually tried RE with the painting. With the 217, it was kind of glitchy, but maybe with RE, it's better because they've fixed things. Are you using 2020 or 2019?
I'm using 2019.
Okay, well, then you want the Unity 217 anyway.
Yeah.
Yeah, I that's the only way to do it. There's no way to like separate, separate out parts of your terrain. It just applies it everywhere.
Yeah, and one more thing, when I use the standard assets, I realized that I only been using like one or two of the prefabs from it or the scripts.
Yeah.
Is there a way that after like importing them, can you like delete them from asset?
You can delete them. Scripts don't take up any space.
Yeah.
Scripts are really, they're not an issue if you have scripts around. The thing that take up space are TIFF images, TIFF textures.
Yeah.
A lot of you are downloading a Skybox HDRI that's a high definition,
High dynamic range, something.
high dynamic range skyboxes, and they're huge. They're like 20
Yeah.
gigabytes each. And yes, you can delete them if you're not using them. When you import things, there's a little there, it shows you the window of what you're going to import, and there are little check boxes next to things. And
Yep.
you can turn off things. Now, be aware that some of the items, particularly ones that use scripts, the scripts may not be in the folder that comes with it. But if you do that and it then says there's a missing script, you can just re-import the thing and get what you want.
Yeah, and one more thing is that so when you import assets, right?
Yeah.
So when you use your mouse and to pull these asset into your scene, so do the game like keep the asset in their original location, or do they actually add these assets to your game folder?
They usually add, if you have an object selected in your hierarchy, in your scene view,
Yeah.
and you add an object, like create a cube, it'll usually put it right where the selected object was. So it'll put it right on top of it. If you drag a prefab in from your project view, it depends how you drag it in. If you drag it into the scene view window, it will go where your mouse pointed it. If you drag it into the hierarchy view, it'll go where it was originally created. So, if the prefab has an original position in it and you drag it into the hierarchy, it'll go where it was created. If you drag it into the scene view window, it'll go where the mouse is pointed.
Okay.
Okay.
Yeah. And I think the homework yesterday that I submitted was like 600 megabyte.
Yeah.
And that's pretty big. That's like much bigger than I expected.
When you brought in standard assets, did you bring in did you get it from the asset store?
Yeah. Yeah.
Okay. So that's the bulk of your game, is all of those standard assets. And what I recommend doing is getting the separated standard assets that I've posted on Google Drive. And what that has is all of the standard assets kind of broken out into categories.
Right.
It has cameras, it has characters, it has vehicles, it has utilities. And so instead of importing the whole standard assets, which is what you did getting it from the asset store, you can import only what you want. And you might have seen when I import the characters
Yeah.
from, I don't bother to import the rolling ball or the third person character because they're both expensive. They have a lot of textures and scripts and FBXs and stuff. I just import the one character that I want. And so I keep the use of space down. So that's a way of doing it. Okay.
Yep. Thank you.
I highly recommend getting the separated form because you're going to be importing standard assets a lot.
Yeah.
And if it does bloat your game up. I actually, as I grade homeworks, I actually clean them out so that I'm only keeping what you guys used. And it often goes from 600 down to about 100. These files are big. They're always big. Another trick for submitting something and it not being terribly big to submit, and this is a little dangerous, you can delete the library. Now, if you delete the library, the next time you load the game, it will take a long time because it has to recompile the library. But I have to do that anyway when I load it into my grading editor.
Yeah.
And so if you submit things without the library, my computer will do that creation, and it cuts the size about in half. The library is fairly expensive for space. So you can delete it, but be warned that if you do delete it, the next time you open the game, it'll have to recompile the whole thing.
All right. Thank you.
Yeah. Anything else? Nate, do you got any
That's
questions?
everything.
Nate, are you there?
Yeah, sorry. I was cooking breakfast.
Yeah, no, that's okay.
All right, bye-bye. Thank you.
So
Nope,
anything
that
else?
was-
I'm going to go if you're all done.
All right, have a good one.
Okay, bye.